So now let's talk about the river or fluvial dominated delta. So a fluvial dominated delta, we will have river that coming into the sea. I'm drawing this river channel. And when river, no matter it's a meandering river or braided river, when it's coming to the sea, the channel becomes more straight than the meandering river. So if this is the river that enters to the delta area, then we're expecting the deposit is in a generally fan shape like this. The delta has a different sub-environments. The area that is always exposed to the air is called the delta plain. And the area that is submerged under the seawater but still has influence from the river, we call it delta front. And the area that almost has no river influence is called pro-delta. And the deposition at those places, no unidirectional flow structures. It's only laminations. So those are three parts of the delta. As we learn the fluvial depositional system, you can pretty much know what is happening in the delta plain area. So the first is that when river water start to reach to a distributary, the flow velocity gonna decrease because it's flowing towards the sea. The energy gonna decrease. So when the energy of the flowing water decrease, there will be deposit at the mouth of the river, like here and here, and those places they all have deposit because of the river start to enter a new distributary, and this is called mouth bar. And within the channel, what type of a sedimentation we are expecting are sandy deposit with cross stratification or cross lamination and ripples. The area that in the middle of the channel, we call that interchannel area. Those are places like a river depositional system. We will have for example, crevasse splay deposition. And with the crevasse splay, also we will have levees. Other than that, of course, there will be soil development in the interchannel area. And there will be vegetation grow on that. This is what we are expecting within the delta plain area. And in the delta front area, the deposition is only happening underwater. However, the river energy still exists, though it is disturbed by wave and tide energy. But the river influences still we can see from the deposition, and we can find unidirectional flow sedimentary structures such as ripples and cross laminations. And once to the pro-delta area, this area is dominated by mud, silt, and the mud deposit, and the delta front area is mainly sandy mud or sand. So in this plain view, it is just a delta that in a modern world, these are the depositional process that we can see from the modern world. But if we want to know the geologic record, we need to consider how does a delta that develop. If I draw a cross section from here to here, from A to B, then what we will see is that this is a continental, this is the marginal moraine area, like this. And this is the A, this is the B. over here. So at the beginning, when there was no delta, what we will see is the on the continental shelf, there will be laminated muddy deposit, and occasionally we will see slumps or turbidity current deposit, which is the Boma sequence. And then a river comes in. So if we consider sea level does not change, okay, I will draw a sea level with my pencil. Let's say sea level is over here. And we know that at this point, from this point landward, this is delta plain area. And from this point seaward, this is starting from the delta front to pro-delta area when the delta develop. So what happened is when a river coming in, the channel has a cut banks and deposit point bars, and then reached here, the river energy going to decrease dramatically. So we will have deposition like this. Okay, and from here, this is the delta plain, and this is delta front, and on top of that, this is the boundary between delta front and the pro-delta. When the next episode coming in deposit, the river, this area was under the seawater, but now because of sediments deposit on it, the land has built, so the river gonna keeps going and then deposit another episode sediments. And as you can see, we are actually developing a progradation pattern. And when the next episode coming in, the delta plane gonna grow to here and then deposit another inclinal form, the progradation. We can see the area of pro-delta boundary is getting towards to the sea. Pro-delta is growing to the seaworld. Okay, and the next episode deposit will be like this. So now the pro-delta is growing this way. So then let's draw another episode of deposit. Then we'll have pro-delta deposition like this. So this is how a delta developed. In different types of delta, this is the fluvial dominated delta and the tide dominated delta and the wave dominated delta. They grow in a similar way. They all develop a progradation pattern and had a river coming into the sea further and further. So if we draw a stratigraphic section over somewhere here to see the sedimentary record of a delta, then what we are expecting is that I'm gonna draw the stratigraphic column of a fluvial dominated delta. Okay, so as I said at the beginning, when there was no delta developed, the area was covered by shelf deposit with laminated mud, and then occasionally we will see Boma sequence. So a Boma sequence contains 5 units. At the bottom is a conglomerate unit deposited by the turbidity current head that has an erosional base deposit conglomerate. And then we will have upper plain bed deposit. That's the B unit. And then as the turbidity current speed continue decrease, we will start to have ripples developed. Ripples and the cross beds. So this is the A unit, the B unit, the C unit, and the D unit will be the lower plain bed of sandstone. And the trend is gradually finding upward, and eventually we will have the shelf deposit, laminated mud shelf deposit. And then we start to have a river coming in to build a delta, and then the river coming in build a delta, we will have the first reached to this area will be the pro-delta. And the pro-delta comes in with the silt and the mud. That is because it's still extra sediments brought by river. So the grain size is still larger than the shelf muddy deposit. So we will have a slightly coarsening upward. And of course, this area is dominated by lamination. So you see, once the delta coming in, because of the progradation has moved the stacking pattern towards the sea, we will have a coarsening upward trend. So here we keep drawing this coarsening upward, like this. And remember, this is let's draw. This is a shelf deposit, and this is a slump deposit, slump deposit on shelf. And this area is pro-delta. And this place is dominated by silt, mud, very fine sand. And the sorting will be very well sorted with well-rounded grains, and the structure will dominated by laminations because these sediments are brought by rivers, so it's also enriched in nutrients. We will start to have more creatures that likes to live here. So we're gonna have burrows again, and maybe some aquatic fossils. Let's draw a clam. Okay, this is a fossil. And then we are entering into the delta front area. Delta front. Remember, delta front is still sub-aqueous deposition, but also influenced by river. And so therefore we will have ripples to suggest this is a unidirectional flow influenced by river. And across laminations. And of course this is dominated by sand deposit and maybe medium to coarse sand. But it depends on what type of river is entering. Also trough deposit, like this. So this is delta front. And within delta front, actually, we will see muddy deposit as well, because there are areas did not influenced much by the river and still deposit with mud. And then we come to the delta plain area. And in delta plain area, we will see more even coarse sediments with ripples, unidirectional flow deposit, cross stratification, cross beddings, and maybe trough cross beds. And we also have a floodplain, not floodplain, this is the interchannel zone deposit. And of course, there are soils as well. And then at last, this area probably occupied by backshore sand dunes with large and high angle cross stratifications. Sand dunes that is actually not part of the delta anymore. It is showing this is the backshore area. It's a sign of depositional fishes moving from the sea towards the land. based on this stratigraphic column, we can see major characteristic of delta deposition is the trend of coarsening upward due to this progradation. So remember when I said that when a delta can develop, it's only because the river brought enough of sediments that can deposit in this area that the amount is more than the wave and the tide can remove and redistribute the sediments. So all the delta development involves sediments progradation. That's how a fan shape of deposit can be built up. Therefore, with progradation, the landward depositional facies gonna move towards the sea. And we will see in the vertical direction, we will see the depositional facies changed from shelf deposit to pro-delta and then to delta front to delta plain and eventually to backshore dunes. So coarsening upward is a sign of a progradation, and that's how a delta can be developed. And the major characteristic of a delta deposition. Here it is a fluvial dominated delta. And it is characterized by very pronounced development of tributaries in the delta plain area with the deposit of crevasse splay and levees. So the river process is very pronounced, and we will see all the subdepositional environment of a river system. And we also will see the mouth bars. So those are the key points of a development of delta system and the key characteristic of fluvial dominated delta. And here within on the stratigraphic column, I only list the subdepositional environments and the depositional facies, but I did not write down what type of rock there will be and what kind of sedimentary structures. I'm expecting when you draw this, you will list the characteristics of sediment texture, including the grain size, roundness, and the sorting of the sediments, as well as the characteristic structures that can be developed in those depositional facies. So when you answer this type of a question about depositional facies, including the texture and the structure, you need to make a detailed answer and make sure you include the grain size sorting and roundness as well as the structures.